You measure 39 watermelons' weights and find they have a mean of 40 ounces, and assume the population standard deviation is 13.1 ounces. Based on this, what is the maximal margin of error associated with a 90% confidence interval? So our interval will look like X bar minus the margin of error, I'll just call it ME, to X bar plus ME. So let's first use technology to compute the confidence interval, and then we'll get the margin of error from that. In order to choose the correct calculator, we need to know what distribution we're using, and here are the rules. Since we're given the population standard deviation, we're going to use the normal distribution because n is 39, which is greater than 30. So we'll go ahead and use this distribution, and let's write down what we know. N is 39, sigma is 13.1, X bar is 40, and our confidence level is 90%, 0.9. So there'll be a link to the set of calculators in this problem, and it's also in the module, but this is what that page looks like. And you're going to go ahead and scroll down to confidence interval for mean with statistics. And this is what that page looks like. And we're going to click on sigma known because it's known, and we just fill in what we have. 39 for n, X bar is 40, sigma is 13.1, and our confidence level is 0.9. And we click calculate. And here I have the upper bound and the lower bound for my confidence interval. Now I'm going to round these to 4 decimal places because I want to round my final answer to 2 decimal places. So let's come back over here where I've recorded these. My upper bound is 43.4504 and my lower bound is 36.5496. Now I want to take that difference to find out the width of my interval. My whole interval, this is X bar centered in the middle, the whole interval has width 6.9008. So this is my margin of error here, and this is my margin of error here. The margin of error will be half that width. So I take 6.9008 and divide by 2, and I get 3.45. So to 2 decimal places up here, we have 3.45 ounces. I hope this was helpful.